Hello, everyone. My name is Artem, and I'm a software engineer at Box. Today, I would like to speak about complexity in tests. But before I begin, allow me to ask you a simple question. Have you ever felt like writing a test for a feature would require more time and effort than the feature itself? Well, like me, you have. Then the chances are you were dealing with one or maybe multiple ways how complexity may manifest in your code base. But you shouldn't feel bad about it, because no matter how great engineers we are and what incredible code we write, complexity is destined to happen. It's fine. Complexity in itself is not the issue. It's how we choose to deal or not to deal with how it manifests what matters. And while complexity can be a broad topic, for the sake of today's talk, I would like to reference to it as a quality or state of being hard to write, understand, or maintain a test. And when it comes to complexity in tests, it can be divided into two main groups. It's the complexity that comes from the system that we're testing, and this can be really any code, a React component, a backend route handler, or a JavaScript library. And complexity that comes from the tests that we're writing. So let's start from the system. And one of the most common ways how people stumble upon complexity coming from the code that they test is that they don't know what to test. I'm pretty sure you've been in this situation. You open an existing file, and it seems to be doing everything possible in the universe, and you have zero idea how to even approach testing that. Well, there's actually a great rule you can follow in these situations. It is, whenever you're in doubt, start by testing the most critical user-facing paths. So if you're building an e-commerce product, well, starting your test strategy from a logging flow or a checkout flow makes most sense. And if you're developing internal tooling or libraries, then start from those happy paths that users expect, and that should set you on the right track. And then when you know what to test, the next biggest problem, the next challenge is how to test that. And I think very often when we feel struggle with how to approach testing, it's because we miss some sort of testing philosophy. And one of the most useful approaches that I've adopted over the years is testing like the user. What it means is that whenever you write a test, try to model it from the user's perspective. So your test actions that you perform would emulate the actions that that user would do with your software. And your assertions that you write actually reflect user expectations as the result to their actions. And then another thing that helps tremendously is when you invest enough into testing setup. And I feel this is very often overlooked, and it's a shame, because the testing setup is perhaps one of the most important phases that deals with the complexity. Because the point of this phase is to create this universe, this box, where any test can run, where any test that you want to write can actually execute without problems. And I'm going to talk about testing setup a little bit later into the talk. Okay, so when you know what to test and how to test, you may be stumbling into another problem, and that is writing too many tests. And it may sound like a good thing at first, but it's not really, because each test should have a purpose. And we often seem to forget the purpose behind testing in general. And we write tests not to gain code coverage or to have the CI passing, although we want that. We actually write tests for a single reason. And that is, we write tests to describe intention behind the system. Think about it. Whenever you write a piece of logic in your code, you have some sort of intention. You want that code to do something. But unless you have an automated test to validate that intention, you have no proof that your code works as expected. So the next time you approach a test, ask yourself a question: is what I'm testing actually related to the intention behind this code? Because if it's not, chances are you can drop this test and still lose no value in your testing setup. And then the other thing is that, well, real world is quite more complex than that. And sometimes there are objectively complex systems, right? Or are there? Because one thing I love about testing is that a testability of the system is an implicit test in itself. Now, what this means is that when you have poorly designed, poorly architectured systems, as a consequence, they're going to be really hard to test. And the opposite stands true also. Let me give you a few examples of how this manifests. So in this getUser function, we fetch user from the database, but we also fetch all the posts for the user. And this feels that it doesn't belong here, because now to properly test this function, we need to also mock everything related to posts, and this is a stretch. What maybe the proper approach here would be to split this one function into two, and test them all in isolation, which would be much easier. And another example is related to dependencies that our code introduces. Like this shopping cart controller, you can see that in the constructor, we're creating a new database connection. Well, maybe that's not a good idea, because to test this controller now, we need to implicitly mock this database constructor somehow. Why not just pass it as an argument to the constructor, do dependency injection, and thus allow us to test, for example, against the test database during testing, which would make this whole experience much easier. But my point here is not to give you some practical pieces of advice on how to write better code. I'm pretty sure you know that already. I'm just trying to encourage you to stick to those past practices, because the better code you write, the better tests are going to be for that code. So best practices matter. So to summarize, how do we tackle complexity that comes from the system? Well, first of all, we establish a clear testing strategy. And when we're in doubt, we're testing the most critical user-facing paths. Then we adopt some philosophy, for example, like testing like the user, which really helps us model our tests easier, and we know how to approach any logic that we test. We need to invest into the testing setup, because it's one of the most important parts of the setup that allows us to write any test we need. And of course, we can use the testability as sort of an implicit check to help us see that the code that we're writing still stands true to the intention that we have for that code. Okay, now let's speak about complexity in tests. And one thing that often comes to mind is that we introduce that complexity ourselves. For example, when choosing the wrong testing environment. Imagine if you're testing a Next.js page, but you decided to do it in JS DOM. Well, you're going to have really bad time, because that environment is not designed to test full pages. The same is true if you decide to test a single JavaScript function and you spawn an entire Chromium instance to do that. Sure, that would work, but is that really the right approach? And to solve this is really straightforward. Choose the proper testing environment. And it is often the environment in which your code is destined to be run. So if it's a Next.js page, just launch it in a browser and automate tests there. If it's a simple JavaScript function, perhaps a Node.js-based testing framework would be enough to test it efficiently. Okay, now the other thing, and it's perhaps one of the most crucial things in the whole testing section, is the testing setup and how very often we lack it. I mentioned it briefly before, so let's go into more detail here. And the idea behind the testing setup is to create this environment where any test that you need can run. And this is why this phase should do the most heavy lifting in terms of complexity mitigation. So this is where you do HTTP request mocking, where you create test databases or mock connection to databases, and tackle any sort of side effects that your code commonly introduces. And this is why utilizing setup and action phases as well is crucial. And let me show you how, using an example. So when it comes to mitigating complexity, you really want to do the most of it in the setup phase, like I've mentioned. One of the reasons why is because you do it once and you have this environment and you can run any test in it, which is great. But then even after that, you're still going to have some occasional complexity coming from the test actions that you perform, because there's very often some logic, some abstractions that we do in testing, and you can just move them into helper functions and utilities and thus reduce the visual clutter, but also complexity of tests overall. And you absolutely never, ever want to tackle complexity on the assertions level. And I'm going to show you an example why just in a minute. But most importantly, keep it simple. I once had a pleasure of reviewing a pull request that had a goal to improve the testing setup. And while it was great, I'm ashamed to admit that it took me around 25-30 minutes just to understand what a test setup was doing for a single test. So half an hour, but I wasn't anywhere near understanding what the test does, what the code does behind the test. No, just the setup. And it's really important to keep this in mind when tackling complexity. You shouldn't really respond to complexity with more complexity, because math still stands and 1 + 1 can equal 2 complexities. Instead, you want to respond to complexity with granularity. So single purpose small functions that in total contribute to creating the testing setup that you need. Okay, now let's talk about assertions. I think in the light of reducing complexity and repetitiveness, we tend to overdo it sometimes. And here's an example for you. So this is an assertion from a test block. And whenever I read any test, I'm actually starting from this expect lines because they're the most useful to me. So in this test, we expect the file content to equal a string. This is pretty straightforward, but it's not what the test does. Because if we look above this expect line, we see that there's a for loop. So we're actually testing every file from a follower to have the same content. And even that is not enough, because there's another loop above, and we're actually testing all the followers and all their files to equal a specific string. Just notice how many things we need to compute in our head just to understand what the single expect line does. So it feels like we're abstracting complexity, but we're actually just adding more complexity to our minds to tackle through. So I believe that a test block is the worst place to get smart. And let me show you how we can redo this expect line to be much better. So this is the same assertion from before, but now it reads in a single line. We expect that all file contents would equal a string. That's all. There's no additional context attached. And if we need to find out where the file contents are coming from, we can just jump to the line that gets them, and we can see, hey, it uses a utility function, so we abstract that logic away, because in actuality, this test doesn't concern itself with how to extract those contents. It only concerns itself about the equality. And then another point relates to test structure. And let me tell you a story. I was once working on a really big project, and it had a lot of tests. And one of the test suite was 4,000 lines of code long. And as it often happens, something went wrong. There was an issue, and CI started to fail. So I jumped into this, and I tried to figure out what's happening. And I saw that this test was failing. This assertion was failing. And I spent a couple of minutes, then half an hour, then an hour, and it just didn't make sense to me because, well, it was like saying I expect 1 to equal 1, and it was false. It didn't make sense. But then I finally figured out that a couple of thousand lines above that failing assertion, there was a before all block that was completely mutating the result of the whole system. And I wasn't very happy about it. But it told me an important rule, is that we should try writing tests that would still make sense at 3 a.m. Because imagine it's middle of the night and PagerDuty wakes you up and production is failing. So you open your laptop and the first thing you do, you go to the test, which is hopefully there, and you try to figure out what's failing and what is the intention, how it's supposed to work. But if you have a lot of smart assertions to compute in your head, if you had a complicated testing setup, if you have this mutable system result, you're going to have a really hard time debugging all that. So you're going to end up pissed, you're going to slam your laptop, and you're going to go to bed. And this is going to be a horrible experience that you could have prevented. And you can prevent it by keeping your tests flat. And here's an example for you. This is a typical test. So we have a describe block that wraps the whole feature. It prepares some environment before all tests. Then it has a sub feature, for example, and it has its own setup. And then finally the test. Even at this simple example, notice how many things we need to keep in mind just to understand what this single test needs. So why not just put it into the test itself and drop the describe blocks altogether? And I hear you, it's going to be pretty confusing and repetitive at first, but in time you will grow to love this because the benefits this gives are just incredible. It's declarative, it's explicit, and you understand what each test needs from the test, from reading the test. And then, of course, you can create and reuse test utilities to abstract commonly used logic. For example, if in this test we fill in a signing form, and we do this very often to test the signing feature, well, why not abstract it into a helper utility and call it sign in? And notice how immediately this reads much better. It reads like the intention. We want to sign in with these credentials. It doesn't matter what are the form selectors, what are the IDs and classes. It doesn't matter. The intention is to sign in and then do some expectations. And of course, one of the most overlooked approaches is that you can split tests. You don't have to stuff all the tests in a single test file. So if you have a complicated feature like the sign-in, and it has different providers like email and GitHub, well, put them into separate test files. And it's going to give you great readability and discoverability for the price of 0. And then when you need to add more logic and more tests, just add new test files, and that's it. The same stands true when deleting features. Because just as good code, good test is the one you can easily delete. It's the test that doesn't introduce a lot of implicit dependencies and all sort of magic in the setup, which makes it really hard to remove. So to summarize, tackling complexity in tests, it's very important to use the test phases properly and to do the most heavy lifting on the setup phase, and then of course reduce repetition in action phase. It's really crucial to express intentions using helper functions like the signing function I just showed you to help your test read like specification instead of a bunch of implementation details. It's really good to keep test structure flat, so perhaps putting everything a single test needs in a single test block, and of course use simple explicit assertions so you don't have to compute a lot of things in your head to understand what the test does. And when it comes to complex features, well, you can also split them on the file system level and gain this great discoverability and great maintenance over time as your product develops. Of course, there's much more to complexity, but that's all I have for today. So make sure to follow me on Twitter if you like this talk and share with me some of your experiences with how you dealt with complexity in tests in the past. I hope you enjoy this and have a great day.